Hello my dear students, I hope you all are enjoying this series. So in this video we are going to derive an alternative formula for curvature, which will be simpler as compared to what we have done. We know that like you must be remembering that how did we find kappa, right? In the last videos we know that dt by ds is kappa times n vector. So from there we were trying to write our dt by ds vector as a scalar multiple of n vector, and then we were trying to find kappa. So that was okay, but sometimes the calculations are hard. So we because you have to separate n vector and then kappa, right? So here we will be looking at an alternative. Having computed the normal and tangential components of velocity and acceleration in the last video, we are equipped with a tool which can give us an alternative formula for curvature. So in the last video we saw that v of t has s dot as its tangential component and no other component, and similarly acceleration has s double dot as its tangential component, and it has kappa s dot square as its normal component, right? So this is what we saw in the last video, and this is the fellow here which I want to find out, right, in terms of VA and all those things. So what I'll do here is I'll do V cross A. I'll take the cross product of these two vectors. So that would be ST vector cross product with S double dot T vector plus kappa S dot square N vector. So if you do the cross product here, so you'll get S dot S double dot T cross T plus kappa S cube T cross N. Right. Now if I ask you what is T cross T, can you tell me? You can write in the comment box. So this is a 0 vector. Why? Because these are the same vectors, so the angle between them is 0, so sine 0 is 0, and the magnitude of this vector is 0, and hence the vector is 0. So this is 0, so the first term is gone, so we are left with kappa s dot cube. Now can you tell me what is this vector here? T cross n. T cross n is b vector, which is a binormal vector. So we get this V cross A is like this. Now if I take modulus of V cross A, both sides, so I'll get kappa S dot cube B vector. So this being scalar will come out, and then I have B vector modulus. This is equal to V cross A modulus. Now what is the magnitude of B vector? That is 1, because that is a unit vector. So from here kappa is V cross A modulus divided by S dot cube. Now if you look at S dot is your V vector, right? Therefore kappa S dot is V vector magnitude. Therefore kappa is V cross A divided by magnitude of V cube. So this is a formula for the curvature of a curve. So this is very important, right? We will be using it all the time. So let me do one problem. So for the path xt equal to 2t cube plus 1 t raised to power 4 t raised to power 5, find the curvature, right? So what you are going to do here, so your xt is 2t cube plus 1 I cap plus t raised to power 4 j cap plus t raised to power 5 k cap. So velocity vector would be differentiation. That would be 6t square I cap plus 4t cube j cap plus 5t raised to power 4 k cap. And then your acceleration vector would be a further derivative, 12t I cap plus 12t square j cap plus 20t cube k cap, right? So we have our acceleration vector, velocity vector, and the position vector, right? Now we can calculate v cross a. So that would be I j k. I j k. I is here it is 6t square 4t cube 5t raised to power 4 12t, 12t square, 12t cube. So that would be I vector. Then you have 48. This is like this, right? Uh, just a minute. This is 20, right? Okay. I'm sorry. This is 20 here. So this is 20 t cube. So if you multiply, you'll get 80 t raised to power 6 minus 60 t raised to power 6 minus j vector, right? So you'll get 120 t raised to power 5 minus 60 t raised to power 5 plus k vector. You have 72 t raised to power 4 minus 48 t raised to power 4. So your v cross a vector is going to be 20 t raised to power 6 I vector minus 60 t raised to power 5 j vector plus 24 t raised to power 4 k vector, right? So you have v cross a as 40 t raised to power 4, 4 t raised to power 4, 5t square I cap, 5t square I cap, and then minus 15 t j cap plus 6 k cap, right? So if you look at the modulus of v cross a, that would be 4t4 square root of 5t square square minus plus minus 15t square plus 6 square. So that would be 4t raised to power 4, 25t raised to power 4 plus 225t square plus 36. And if you look at the velocity vector magnitude, so we have our velocity vector here. We can find the magnitude. That would be 36 t raised to power 4, right, plus you have 16 t raised to power 6 plus 25 t raised to power 8. Okay, so if you try to do it, so this would be velocity vector magnitude would be t square would be out. Inside you have 25 t raised to power 4 plus 16t square plus 36. So you can use it here. So this is our t square 25t raised to power 4 plus 16t square plus 36. Therefore, curvature is v cross a magnitude upon magnitude of v cube. So that would be 4t raised to power 4, 25t raised to power 4 plus 225t square plus 36, and then you have to take the cube of this. So that would be t raised to power 6 25 t raised to power 4 plus 16 t square plus 36 raised to power 3 by 2. So this would be 4 25 t raised to power 4 plus 225 t square plus 36 raised to power half divided by 25 t raised to power 4 plus 16 t square plus 36 raised to power 3 by 2. So this is our answer, right? So you see, you can enjoy an alternative formula for curvature, which can be useful in many situations. Thank you for watching this video. Please share this video and subscribe to this channel. If you have any comments, please write in the comment box. Happy learning.